as much as you can off your calculator. It will make you faster. So first of all, we're going to talk about area of a rectangle because that's what the first shape you learn how to find the area of. They probably in elementary school had you maybe draw it like they're called arrays. Like this would be a 1, 2, 3, 4 by 3 box array, and there's 12 boxes in there, and the area is 12 square units, and you can see the 12 squares in there. That you should already know. That area of a rectangle is base times height. You can see that if I drew a triangle on there, I'm going to change my color here to blue. If I just drew a triangle like that, it would be a half of the shape. So when we get to triangles, there's a half in our formula. By the end of the chapter, you're going to have a lot of formulas. Some of it you've never done before, like areas of a pentagon. None of you would know how to find that right now. And some of them involve trigonometry, so SOHCAHTOA is coming back later as well. But the first few sections are pretty straightforward area formulas. Our first one is for the area of a parallelogram. It is also just the base times the height. Here's why. If you were to cut this sucker off, like if I took some scissors and cut this blue piece off, so pretend I sliced that off, and then I pasted it over here, the resulting rectangle has the same area, and rectangles are base times height. So parallelograms, it's still base times height. The thing you have to be careful of is this H right here. So we're going to go point at it, and we're going to go right there. Finding the height, it's always perpendicular to the base, and sometimes they draw it outside. So like sometimes they'll drop it right here and maybe put a 7 on it, and maybe there's a 5 over here. The 7 is the height. It's the one that goes perpendicular to the base, even though it doesn't hit it. All right, so the first thing is make sure you know that that height is perpendicular to the base. So on this one, my base that I have 2 of them. I have 4.5 and 5. But the one that I have a perpendicular drawn to it is the 5-inch. So this would be the base and the height through that base. All right, so this is just going to be 5 times 4, and don't go to your calculator. It's a 20. And then labels are important this chapter as well. You're actually doing inches times inches. And anything times itself means you square it. So we're going to have 3 different labels by the end of the chapter. Things that are labeled in just inches, like the height of this was. Things that are labeled in square inches, that's going to be anytime we're working with area. And things that are labeled in cubic inches, which is when we work with volume. So on this guy, if I were to ask you, and I'm not because I'm recording and they can't hear you, if I were to ask you which base are you going to use, 4.6 or 2, you would say 2. Not because it's on the bottom. It's because it's the one that you can see the perpendicular drawn to it. So my base is 2. On the worksheet, everybody look up here for a second. They're going to try to trick you and also label this piece over here. The base is still 2. Okay, so the base has to be a part of the parallelogram or a part of the triangle. So on this one, it's just base times the perpendicular height drawn to it, and that would just give you 7, and then it's centimeters times centimeters, which is centimeters squared. So really an easy formula to work with. Just be careful what you think the base and the height are. Now we're going to move on. Like that you should have done in middle school, right? That's pretty familiar. This one they probably wouldn't have done in middle school. It's just got a little twist to it. So it says in this parallelogram, what is the length of DE? So I'm going to go like this, and you should as well, and I want you to put an X on there. That's what I'm looking for, okay? It is a height. How do I know it's a height? Because I see this perpendicular box on here. So I know I'm looking for a height of the parallelogram. I know the base that it's perpendicular to is 9.4. I know that 9.4 times x has to give me the area because it's base times height. But I don't know what the area is yet, except I actually know another base and a height to that base, correct? I know that I've also got over on the other side, I've got a base of 13. So I'm going to go grab my highlighter here. I also can see I have a base of 13 and my height to that base. You might say, well, it's not even in it. It's not. but it's still the height that's gone perpendicular to that base. So if I did 13 times 9 on my calculator, right, 117 would pop up. That's not the answer to this question. That would be the answer to what is the area of the parallelogram. But if I know its area is 117, that'll help me find x. Because now if I work down here, I can say base, which is 9.4, times the height to that base, which in this case is the x, has to be equal to the area, which I already found. So I kind of had to manipulate the formulas a little bit. So I was looking for this height, and I'm like, the area is 9.4 times x, but I don't know what that is. So then I went to the other piece of information and actually found the area using this base and height. So then you're just going to hop on your calculator and divide 117 by 9.4. Somebody's got to tell me what that is.
12.4.
Yeah, and it says to the nearest tenth. Now be careful with your label. It wouldn't be inches squared, because in this case it's just a height. It's a singular dimension, so it just needs a singular. You're looking for a height, a base, a perimeter. Those are just inches. When you're looking for area, that's when you square it, and we have points for that. So next thing is the area of a triangle. The triangle's area, if you can see, if I draw this like this, if I drew that exact same triangle over on the right-hand side, which they did over on that one, I would have a parallelogram with a base and a height. Parallelograms are base times height, so I still need to do that. But the triangle only takes up half the space, right? So there's always 1/2 times the base times the height. Now, if you want to make it go kind of quickly, sometimes like this, I'm going to draw this, and I'm going to go like this, and I'm going to say this is 20, and this down here is, let's say, 17. To make your homework go quickly, right, and you go, oh, this is 1/2 of the base times the height, instead of going to your calculator, multiplication is commutative. What that means is you can do it in any order. So if you wanted to get done in class and stay off your calculator quite a bit, you could say, well, I'm going to do 1/2 of 20, 10, 107. Yeah, that'll make you go a little faster. So sometimes if there's one that's easy to take 1/2 of, like if this had been a 77, who wants to do 1/2 of, and you're like, oh, I need to go to my calculator. No, it's just 1/2 of 20. You don't have to do it in the order that it's listed. Does that make sense? So try to stay off your calculators if you want to use the most of your time. So the one thing to be careful of is, again, I'm going to go over here. Sometimes this height is not in it. Okay? So you have to be careful if they draw it on the outside of it, and we'll get to that in just a second. So our next example is with a triangular sail, and we are supposed to find how many square feet. All right, so it's telling us we have to get all the feet. If it said square inches, we'd have to get all the inches. So I'm going to go over here and write my formula down. And Miss L knows that by the end of the chapter, when you have a bunch of them, finding the right formula is really important. We have 2 today, but by the end of the chapter, we'll probably have like 10. So tomorrow we get 3 more. We get trapezoid, rhombus, and kites formulas. So the minute you see a triangle, you're going to go, I need the formula for the area of a triangle. Okay? And then you're going to look at it and you're going to say, do I know a base to which there's a perpendicular height drawn? And you're like, well, yeah, sweet, right here, this guy. But you're not going to do 13 and 4 inches, and you're not going to do 13.4. It says to go to feet. So you have to convert your 4 inches into feet. How are you going to do that? Almost. 4 divided by 12. Yep. So we would do 13 point, and let's go to the nearest hundredth. 3.3. And I got the 3.3 from doing 4 divided by 12 feet. So you might want to put that on your picture. That's 1/2 of the base times the height, which is 12 feet, 2 inches. I need the 12, but I need to have it written all in feet. So again, I'm going to take this 2 inches on my calculator and turn it to feet by divided by 12. So you need to do 2 divided by 12 on your calculator. And go ahead and tell me, I think it's 1/7 if I round, correct? All right, now I have to use my calculator. So sometimes, I mean, I don't know what that is without a calculator. If you don't like using a half, use 0.5 times 13.33 times 12.17, and we'll round that. Let's do it to the nearest tenth, because it doesn't say. And I'll steal, it was 80 point something from last hour. 80 point what? 81.1. Okay, now my label, it's a two-dimensional. I multiplied feet by feet, and so I would do feet squared. So if I was making that sale, that's how much material I would order. I'd probably round up to 82, right? Just to be sure I have enough. All right, sometimes you're going to have two figures. There's a couple tricky ones on your homework with these that have some good problem solving. But this is going to be, I don't know how to find the area of this guy as it stands. But if I split it right here, I can do the parallelogram or the square plus the triangle, right? So the area of the square is base times height. And you remember these little markings mean they're the same. So that's 6, this is 6, this is also 6. And you're going to be using some of that on your worksheet. You're going to be like, well, they didn't give me this, but then they might have given you over on the left. You kind of got to watch what they give you. So this area would be 6 times 6. And then this one would be 6 times 8. Tell me what's wrong with mine. Just make sure you're paying attention. What's wrong with it? A half of it. Now, if you're going to your calculator to do that, you're just going to be slow. You're going 6 times 6 plus 1 divided by 2 times 6 times 8. Meanwhile, I'm going 36 and saying a half of 6 is 3 times 8 is 24. That's a nice 70. And I'm the person who turns in my homework really fast. So if you're like, how'd they finish so fast? They probably stayed off their calculator for easy arithmetic, which you should really try to do, because kids' arithmetic is getting worse and worse and worse as my years of teaching go on. All right. Would you agree, Miss L? Arithmetic's getting worse and worse and worse as it, yeah.
It's
So
because it's dang phones.
Oh, it could be the dang
Yeah,
phones.
probably.
But
Kids these days.
something like this on your homework, again, if you're doing it on your calculator, there's a lot of buttons to push. I got that answer like in 1 second, right? So be careful with that. Now there's some cool ones on your homework, and I want to stop for 1 second. There's one when you get your homework that's going to have like a triangle like this, and then another one like this. And you're going to know the height. Maybe it's 10. You're going to know this height. Maybe it's, I don't know, 6. And you're going to know this whole length. They're going to label it. I'm going to pretend it's 20. And actually, these went up to the same, sorry. The triangle went like this and like this and like this. And you're going to be going, well, how do I know what this is and this is? And you're going to have to actually yourself draw in a line to make it a parallelogram. Mine doesn't look very good. And if you did that minus this triangle, so you're going to have to be kind of clever with how you split some of them up. All right? I think we're almost done. Nice, easy, fast notes today. It says in a parallelogram, so I'm going to draw one. It's base B, so I'm going to draw one of the bases, and it's height H. I'm not going to put that over here, because that's just another side of the parallelogram. I could draw it here. I could draw my height here. I could draw it over here. It doesn't matter as long as I'm dropping it from the top, perpendicular to the base. So I think I'll put mine out here on the outside. So what they're telling me is that they're in a ratio of 5:3. Those of you who had me first semester, I used to tell you, go put a 5 and a 3 on it. And I used to say that's what they need to reduce to. It might be 5/3. It might be 50/30. It might be 10/6. I said, you don't know, but I said you have to introduce something. Do you remember what I told you to introduce? X. Those of you who had me, I said, introduce X when you have a ratio. Either up here, or if you're going to draw a picture. It means it reduces to that. So I'm going to work with the problem as normal. I'm just not going to use 5 and 3. I'm going to use 5x and 3x. It says the area of it is 135. So I've got the area of my parallelogram. Again, by the time we get to the end of the chapter, I'm going to be having you write those formulas on every problem. Today we only have 2, BH and half BH. So you don't need to do that today. But once we have, 6 plus formulas, I'm going to start saying, I need you to make sure you find it. So like when it says area of this kite, find the kite's formula and you write it down. So I'm going to write it down. My area is base times height. My base is some multiple of 5. My height is some multiple of 3. And my area is 135. And I solve it as normal. I'm just trying to figure out, well, what's that missing dimension? So I go and I say, well, I don't go to my calculator. 5 times 3 has always been 15. X times x is x squared. Brianna, what would I do to solve this? I'm trying to figure out what x is. What'd you say? Almost. Not quite yet. Before I square root it, I need to get rid of the 15. How will I get rid of the 15, guys? Divide, yeah. Divide by 15. If you need your calculator for that, that's where you're slower than the person who knows 135 divided by 15 is a 9. All right, that has to equal x squared. And now I'll do what she said, which she said to square root it. Technically, there are 2 numbers that multiply to equal 9, positive and negative 3. But these are bases and heights of a parallelogram, and they can't be negative, so you are okay just doing the positive. Be careful, because that's not what it asks for. So again, back to first semester, I always say go back and see if that's what you're asked for. If so, move on to the next problem. But this is to actually find the base and the height. So I'm going to put my 3 in here and say my base is equal to 15. And I'm going to put my 3 in here and say my height is equal to 9. And then, how could I be 100% sure I got it right? Oh, yes. And multiply them. And they work. 15 ninths reduces to 5 over 3, and 15 times 9 is 135. That's it for notes. That's pretty quick, right? So what I want you to do with your packet, before I turn the recording off, we're going to talk through just 3 of them together. Go ahead and rip it off the back. It's nice. They rip off in order this time. The packet's actually nice and ready to roll. So go ahead and rip this off. It's due tomorrow, but as usual, if you finish, which you can see a lot did last hour, you can turn it in. There's 3 we're going to do together. All right? The first one is number 7. I'm going to purposely stay off the whiteboard to make sure you sort it through. So I'm looking at number 7, and it says to find h. H is a height of the parallelogram to one of the bases. And it's the height to the base that's 4 long. It's not labeled over there on the left, but it's parallelograms, opposite sides are congruent. So if I were you, I'd put a little 4 on the far left and a little 8 on the bottom. That's using another chapter that opposite sides of a parallelogram are congruent. So I'm looking for the height. I have no clue what it is, right? But I can find the area of the parallelogram. Who wants to tell me how to find, if it said to find the area of that, what 2 numbers would I multiply?
Probably like 4 and 8.
Nope. 8 and 3. Why not the 4? I'm glad you said that. It's not perpendicular to that base. So you're going to go to your calculator and just, you're in your head. 8 times 3 is 24. So you know the area of that is 24. If that was the question, like it is in 1 through 6, you're done. But it's not. We need to figure out the height. So now I have to say, well, I have another base length, 4. Correct? What's the height to that base? Well, it's the h. So you're going to say 4 times h has to equal the area, which we just found. So 4 times h has to equal what? 24. And if you go to your calculator for that, you're slower than the person who just goes, oh, the answer 6. Okay? That one's done. The next one we're going to do is number 15. Because you're going to be sloppy because you're going to think these are easy. So at number 15, my formula is a half of the base of the triangle that I know. What am I going to use for my base length? So I want you to write 1/2 times. What's the base of the triangle that they gave you? Is it 5.5, 10.5, or 5?
I'd say 5.5.
It's 5.5. Yeah, be careful. It has to be a base of the triangle given. So it's a half of 5.5 times the height drawn perpendicular to that base. What is it? It's not in the triangle, but it's 10.4. Yeah, so number 15, you're going to do half of the base of the triangle, which is 5.5, times the height drawn to that base, which is 10.4. All right, flip it over. We've got one more we're doing together. It's number 22, and that one I'm going to draw. So I told you there's some of them you kind of have to be clever because they're mixing the shapes together. So on number 24, they've got this weird shape. They give you a 6.5 here, and they give you a 5 right here. They're telling you this is a rectangle by putting those little right angle boxes in there. And then they give you a 14 down here. And you're supposed to find the area of all of this, which we don't have a formula for the area of a whatever this is. But we do have parallelograms and we do have triangles. So where do you think I'm going to draw my line so that I can split it? There's several options, but there's a best place. What do you think, Avery? If you had to chop this into parallelograms and triangles, because that's all we know today. Yep, Mark?
Down the middle, like
Yes,
that?
right there. So now you have a rectangle staring you in the face that's base times height. So I'm going to do rectangle plus the triangle. My rectangle I put first because it's easier. It's just 16 by 5. My triangle is 1/2 of, and then I've got to be careful because when I do that triangle, I'm going to go shade it in blue. See if it'll make it a, that's not doing that. So here it is. So the triangle that I'm shading in right now, I don't know its base or its height in my face. I don't directly know its base and height, but I can figure it out. Okay, so I want you guys to stop and see if you can correctly fill in the base and fill in the height of the triangle. Neither one is labeled. This base is not labeled. This height drawn perpendicular to the base is not labeled. But there's enough information on there for you to figure it out. So you do have to be problem solvers. When you think you have them or you're stuck, just put your pencil down and then we'll fill it in. All right? And then I'm going to turn off my recording and you guys can just work. So you're finding the base and you're finding the height. They're not directly given with you. None of those numbers up there are going in those red boxes. You're going to use them to get the numbers that go in the red boxes. Okay? So I'm going to start with the base length. I do not know this, but I know all the way across is 14. And I know this, because it's a rectangle, has to be 5. So if I did 14 minus 5, I could get the base of this rectangle. How many of you had that? Good chunk. All right. I also don't know the height of the rectangle, but I do know that this whole way is 16. And I know this piece is 6.5. So their difference, so when you do 16 minus 6.5, what's that, 9.5? That's going to see how these two add up to 16. The opposite sides have to be the same. Then you're going to hop on your calculator. And I would for that one. It'd be 80 plus, I don't know. I'd hop on my calculator for that. Somebody go do it and tell me the final answer.
122.7.
Awesome. 122 point. Does it say what to round to? It doesn't. So let's go.
No, that doesn't seem correct. That's 85.5.
No.
Okay, do 9 times 9.
I'm not doing 9 times 9. I'm doing 9 times 9.5.
Oh, wait.
Anyway, so up here I have to label it with, what was it in this one? Meters squared. Huh, I got a little loop-de-loo on my meters. All right, so your task for the rest of the hour is to try to finish that. If so, turn it in. I don't care if you work with somebody, but go back to number 1 and work it out.